Hi everyone, we're just going to have a little bit of a look at bearings just to jog our memories of how the different angles can be considered for different positions. So to start off with, in mathematical representations, so when we have angles in vectors and in complex numbers, which we haven't had a look at yet, complex numbers, and also on the unit circle when we're thinking about periodic function, angles are always measured from the positive x-axis in an anti-clockwise direction for positive. So if we have a position here, the angle is measured off the positive x-axis in an anti-clockwise direction. We've talked about it a little bit before, that if you had an angle over here, you could talk about it as having a negative direction, or you could think about it going all the way around, the whole rotation around, getting to the same position, and it could be a positive, and that would be 360 degrees minus alpha, whatever alpha is. So that's angles when we think about vectors, when we think about complex numbers, when we think about unit circles, or when we think about periodic functions. I'll add that in as well. Periodic functions. That's how we're considering the angles. When we're thinking about bearings, we can think about bearings in two ways. We can do true bearings. Now, true bearings are always measured from north, and they always go anti-clockwise. So our north is our 0 degrees. That's where we start. And it's always anti-clockwise. Not anti-clockwise, sorry. It's always clockwise. Always, always, always clockwise. Okay, so if we have a bit of a circle here, up the top is north, that's 0 degrees. Out to the east is 90 degrees, true. Down in the south here is 180 degrees, true. And over in the west is 270 degrees, true. We also have compass bearings, and these are probably the bearings that we would use most in just everyday life. So compass bearings, you can either start at north or south, and then they're measured east and west. So they're measured, you start at north or south, and then you measured, whoopsie daisy, east or west. So if we start here, you can start up at north, or you can start up down at south, depending on where you're closest to, and then go east or west. So if I had an angle over here, if I was at a bearing over here, I'm in the northern part of the circle, the northern hemisphere, up towards north. I'm closest to north, so I'm going to use north to measure it, and I'm over towards east. So I measure the angle from north to east, and I say the angle is north theta degrees east. If I had a position over here, I say that it's down in the southern section, the bottom section is down towards the south, it's closest to the south, so it's going to be south, and then it goes towards the west, so it's going to be an angle south alpha degrees west. An angle in the fourth quadrant here would be south however many degrees east, and an angle in the second quadrant would be north however many degrees west. So just an example, just a very quick one, how you would change, or how would you go from a bearing, especially a true bearing of a vector, or if you've warped a true bearing in there, so that would be theta degrees true. Now if we wanted to use that in a vector problem or a vector diagram, we can't use that theta degrees. We have to consider the angle from the x-axis upwards. So our direction, if we're going to think about it in terms of vectors, would have to be 90 minus theta degrees. That would be what our direction is, 90 minus theta. Now if we were to have the opposite way around, if we had found the direction in terms of a vector, that would be measured from the x-axis upwards, or downwards for a negative direction. If we wanted to change that into a bearing, basically we can either consider it as being from north. So from north here, if I measured that around there, that would have to be 90 minus alpha degrees true, depending on what alpha is. And for a compass bearing, in this particular case, it's in the first quadrant, so that's going to be northeast. It's in the northern bit towards the east. So it's going to be north 90 minus alpha degrees east. Now both of these ideas can be adapted depending on the situation we have, but I've just gone with the easiest, most simplest situation. If you need any more help with this, just give me a yell. Let me know what it is that you'd like to talk about. But this is basically how you switch between angles in vectors and complex numbers and unit circles and periodic functions to bearings, which we might use in a contextual situation. So I hope this makes sense. Hope it helps. And I'll talk to you soon. Okay, bye.